Well, good day, everybody. Welcome to the first of three 596A presentations that will take place over the next couple of days. Glad everyone can join us. We have 6 speakers with us tonight, and I hope you're ready for some good presentations. So each presenter will have 30 minutes in total for their presentation. We ask that if you get questions in the chat to please verbalize the question so that the question can get recorded and then answer the question. And I think that's all the real basic ground rules here. So first up is Crystal Perry, who will be talking to us this evening about GIS approach to water wells site locations. So Crystal, whenever you're ready.
Yep. So as it was discussed, my project will be a GIS approach to finding wells in South Africa. The image on this slide are the 9 provinces, which I will go over later during this presentation. Africa is considered a water scarce country. Water scarcity is when the demand for water exceeds supply and available water resources or approaching or exceeding sustainable limits. This country has both a failing infrastructure and increasing population. This led to overcrowding of communal taps, dangerous boreholing, and unsafe acceptance of contaminated groundwater sources. In my study in South Africa, it is interesting in that this area has wells that are full of water, and it is also still considered a water scarce country. So what is going on? This is due to the fact that the infrastructures in South Africa is below average when compared to countries such as Nigeria and Zambia. The quality of the infrastructures and poor management of the infrastructures in this area has led to poor and decaying wells. So this slide shows the physical and economic water scarcity in Africa as a total. The 2 terms that I would like to go over for this slide are physical water scarcity, which is when the demand of the population exceeds the available resources of the region. This could be from severe environmental degradation, decline in groundwater, and water allocation that favor some groups over others. Economic water scarcity is when there is adequate water supply, but there is a lack of available water from lack of water investment, such as water infrastructures. This map was reported by United Nations in 2011. In North Africa, it was considered an arid region, and the water scarcity is related to physical water scarcity. The sub-Saharan region has economic water scarcity, and the later regions have good physical water, but it is constrained due to poor infrastructures. This slide shows some consequences of the water issues. The first bullet is agriculture. This is very important in that agriculture counts for about 14% of the total gross domestic product in Africa. Agriculture is heavily reliant on water. It can also affect the health issues. If the area is water scarce, you will find water at any means possible. And this may mean getting water from contaminated areas such as ponds and streams. This can bring on diseases such as chloria, typhoid, salmonella, or gastric issues, dysentery, to name a few. This can be a dangerous thing for Africans in that the quality of healthcare is very low. Only about 48% of Africans have any access to healthcare. Water scarcity can also lead to food insecurity, and that 70% of fresh water withdrawals go into agriculture. And like I said, agriculture is a big product in Africa. Eventually, water scarcity could lead to human conflict due to competing for water. This slide goes over groundwater versus surface water. Groundwater is water that exists under the ground in saturated zones, such as beneath the land surface. The groundwater fills the pores and fractures in underground materials, such as sand, gravel, and other rocks. The layer of water bearing permeable rock rock fractures are the aquifers. Groundwater can be cleaner than surface water in that it is underground, not collecting contaminants. However, that does not mean that it is uncontaminated. It can be contaminated, for instance, from fertilizers from farmlands. Groundwater can be affected by porosity, permeability, transmissivity, and recharge. Porosity relates to the gaps in the grains of the rocks. When there is a lot of gaps in the rock, it will have high porosity and be able to hold more water. Permeability relates to how water moves through the rock. Good permeability, therefore, means the water is able to move through the rock layer. Transmissivity is the rate at which water can flow through an aquifer. Recharge is when water seeps into the ground to replenish underground aquifers. I will go over this more when I discuss soils later on. Lastly, good water is accessible. Groundwater is accessible through periods of droughts. So when it's drought, you're able to get to the groundwater more easily than it is with surface water. Now with surface water, it is above the ground that forms terrestrial water bodies. Surface water can be more contaminated than groundwater can. It can become contaminated from numerous things, such as from sewage, accidental or deliberate spills, erosions, or from runoff. Surface water will need to be treated to be safe for human consumption. South Africa is located at 22 degrees south to 35 degrees south and 17 degrees east to 33 degrees east. This country has 9 provinces that are shown on this slide. I am unable to pronounce some of these, so they're just listed right there. These provinces are then divided into metropolitan and metropolitan district municipalities. The municipalities are then divided into local municipalities, which are then divided into wards. There is no significant lakes in South Africa. However, there are artificial lakes that are used mostly for crop irrigation. The large river in South Africa is the Orange River. This joins the Caledon River that's between Eastern Cape and Free State. The river empties into the Atlantic Ocean and creates the border of Namibia. South Africa has a subtropical climate with an average annual rainfall of about 464 millimeters. South Africa has a greater elevation above sea level compared to other areas of similar latitudes. This leads to this country having a lower temperature. The average temperature, for instance, in Johannesburg is 30 degrees Celsius average in the summer. The nighttime temperature, however, can get to freezing point. This is an overview slide of my problem set. As a reminder, South Africa is a water scarce location due to poor well infrastructure. For my study, I'm going to be finding groundwater potential areas in South Africa. I will then create groundwater potential map for those areas. Then I will create a second map to subtract areas that could be contaminated for my well map, such as near farms or near roadways. This slide shows my methodology and approach. I will discuss this in the next few slides. First, I will be using a GIS-based multi-criteria decision approach. This type of method helps you determine the best alternative by considering more than one criteria in the process. I will have several criteria for my analysis, such as drainage density, slope, lineament density, land use, land cover, soil, geology, and rainfall. This type of method aims in the decision-making process, such as where the areas of groundwater are most likely to be. Each of the criteria will be created through a rasterized map with a scale of 1 to 5, from low to high. I will then use the AHP method, the analytical hierarchy process, to organize and analyze my decision. The AHP method is a pairwise comparison method that is used to applying weights for all my classified raster maps for my criteria into one groundwater potential map. This is just an overview of what MCDM is, as discussed previous. It's a way to structure my data to make better informed decisions. I will apply weights to each of my criteria maps from 1 to 5 as discussed, from low to high probability of the groundwater potential. In the next few slides, I will go over my criteria maps in the process of the MCDM process. With all the maps, I will reclass all maps from 1 to 5 as discussed. This will help later in the process when I create the final map. The next few slides will go over my thematic maps. The first map I will go over for my criteria will be drainage density. Drainage density is the total length of the channels in a watershed that's divided by the total area of drainage in the watershed. When viewing a drainage density map, the higher the drainage density correlates to a lower probability of groundwater. The created map will show areas very low to very high drainage density. This map will be created using a Strahler method in the hydrology tool in MGIS. This method uses a hierarchy of streams from top to bottom. It essentially joins the streams of the same order. The image on this slide gives you an example. So if you look at stream 1, they are the upper channels to the first confluence, or the point where the streams meet to become the river. The second order is below the first 2 order streams, and the third order is joining the second order stream, and it can keep on going in that way. Knowing the stream order, you can give clues to the size and depth of the channels. First, I will go over the alignment map for this slide. Alignment map features are faults in the surface. Lineaments have an increased permeability and porosity. The alignment map will help with classifying understanding of surface water and associated faults. I will create this map by creating hillshades in ArcGIS Pro using dim layer. 4 different hillshades will be created with different azimuths for the purpose to display and ensure that I capture basically all the alignments. The azimuth is the angular direction of the sun. The degree starts from north and moves in a clockwise direction back to north from 0 to 360 south. The default is at 315 degrees northwest and 90 degrees. 90 degrees. I will also have to play around I will just have to play around with what azimuth I put in to try to capture everything. After the hillshades are created, I will create shape files using polyline to show the alignments. Then I will use the lines density tool to create the alignment density map. Now for slope. The slope can be defined as the steepness of the ground surface. The slope is measured from the rise over run. The rise is known as the increase in elevation. The run is the horizontal distance. Slope will be created with the SRTM dim, and I will be using the tool slope in ArcGIS. The SRTM will be downloaded from NASA Earth Data and will have a 30-meter resolution. There was a 90-meter resolution, but I have not been able to download it yet. I will look into that later. Now this is a land use and land cover map. One second. Okay. Alignment feed. My slide is messed up. I'm sorry. I will be using South Africa National Land Cover raster, but we'll be reclassing the data to 5 different classes: water bodies, vegetation, built up areas, agriculture, and bare lands. This will help when applying weights and reclassing 1 to 5 for groundwater potential. For example, higher weights of water bodies and lower weights for bare lands. The soil type affects the water recharge and water holding capacity of the area in terms of groundwater. The larger the surface of the soil, the more it is and able to retain the water, and therefore will have a greater capacity to retain water. For instance, sandy soil has a coarse particles and will retain less water than clay, which has smaller particles. Later on in the process, soil types will be classed by how effective the soil type is able to hold the water. For example, clay will be ranked higher than sand. I have downloaded the data from ISRIC World Soil Information for Africa. There's also a layer in MGIS portal that I may look into as well. The image on this slide shows examples of soil types. So it shows sand, loam, clay, and silt for that. Next is the geological map and rainfall map. The geological map will be downloaded from ISRI portal. South Africa contains acidic, plutonic, acidic volcanic, sedimentary, mixed sedimentary, non-acidic, plutonic, volcanic, carbonate, and unsolidated rocks. I will need to figure out how to classify this map in order to apply my weights. I will need to try to figure out on a scale which types are more or less permeable. In other words, I need to research some data and see which are more or less permeable before I classify. My last map that needs to be made in class prior to the AHP process is the rainfall map. The layer will be downloaded from ISRI. This layer was created from NASA Global Data Assimilation System. It is from 2016 to present and shows the annual rainfall. The higher average of rainfall will receive a higher classification of 5, and a lower average rainfall will receive the lower classification of 1. Now that all my criteria raster maps are created and classified from class 1 to 5, I will perform the AHP part of my study. As discussed, this is a pairwise comparison using criteria weighting. Essentially, I am trying to figure out mathematically for GIS how much each criteria is weighted as a percentage of the whole as a map. I will be using an Excel spreadsheet that was created by Gloss GeoPel to help with my calculations. That is what you see on my slide. I will enter each criteria in the blue part on the slide that you see on the slide, such as rainfall. Below that, you will compare each criteria one at a time to each other. For instance, rainfall, it will be compared to all the other criteria. The first column you input, column A or column B, is which one is more or less important? Is it column A or is it column B? And then the second one, you list a number from 1 to 9 of equal or less important. So number 1 will be equal importance. Number 3 would be moderate importance. So you put one of those numbers in, and then it'll calculate it for you. The Excel spreadsheet will then automatically place it into a matrix vector, and the weight is calculated. It will tell me a consistency ratio, and a consistency ratio of 0.1 or 10% is reasonable, or less is reasonable. If it's greater than that, it will tell me that something is wrong with my spreadsheet, with my calculations basically, and I need to relook at it and redo it. Now that my Excel calculations are completed and I get a good percentage, my thematic maps are also completed with classes 1 through 5. I can now use ArcGIS to create my final groundwater probability map. I will use a weighted overlay tool to apply my weights. I will use an Excel spreadsheet to enter the percentages into the tool for each of the maps. This will be the percentage of influence for the calculations to sum the influence, and that should equal 100 by the end. I will use evaluations of 1 through 5 for each of the maps, low to high porosity or probability, I mean. I will ensure that my ranks are appropriate for each of my criteria. As an example, if looking at alignment in the tool, I will enter a high alignment density as a high rank, then a least alignment density as a low rank. For slope, the less of the slope, the higher the rank. This is due to the chance of runoff with a higher slope. After running the tool, the map is created. I can then add a field to the table to calculate the areas of probability. And then I can also create another map to remove areas that can be contaminated, such as near farmlands or near roads. Final product, as discussed, I will have 2 maps created, one of the groundwater potential of high probability to low probability to have groundwater. A second map will also be created by removing areas that could potentially be contaminated, such as near agriculture, from my well sites. The conference that I'm looking at is American Water Resources Association, and it's November 6th through the 8th. I just felt like this is a good conference because it deals with water. They deal with water issues, and it's also close to my home. And that is pretty much it. If you have any questions.
Okay, thank you very much, Crystal. It was a great presentation. While we're waiting for some questions to pop up in the chat window, I was wondering if you could maybe give a little bit of background on why you chose South Africa for your study.
Okay. Well, it first started, so I wanted to do wells because that hit home. I was at a church event and they were doing a bunch of wells. So that really hit home to me. So when I started looking around, I noticed that South Africa is first a water scarce country, and then it's a food scarce country. So then that made me research it even further. South Africa also has, I can pull data a lot easier than other areas in South Africa. And then I also noticed that South Africa is not that it doesn't have enough water, because it has enough water. It's the infrastructure that needs improving. So I felt like that would be a good combination to do the product on.
Okay, good. It looks like you have a question in the chat window.
It says, what are some of the following follow-up projects you are hoping would? So the concern with my study is so a lot of the studies, they test water, which I'm unable to do. So I'm hoping that they at least look at the areas of groundwater and be able to test the water. And it could also be applied to other areas, not just South Africa, just Africa as a whole is what I'm hoping. Because it's helpful to find all that groundwater at least. A lot of the studies, they have studied surface water, which is contaminated.
Does anyone else have any questions for Crystal? All right, Crystal, if you wouldn't mind putting your contact information in the chat window in case someone wants to follow up with you at a later date.
Yep.
Next up, we have Marissa Williams. So Marissa, if you want to start sharing your screen. All right, we see your slides, so it looks good. So
Okay,
Melissa will,
perfect.
yep. Anytime you're ready, you can go ahead and start.
Okay, I think I'm ready now. So as you can see, the title of my presentation is Mapping the Future of the Human-Wildlife Interface on Smith Island. There we go. But before we get to exactly where Smith Island is and what Smith Island is, I just wanted to cover the Chesapeake Bay since that's where it's located. And then another thing you'll notice throughout my presentation, I have numbers in parentheses. That's just referring to which source down in my references at the very last slide. They're all numbered. But the Chesapeake Bay is the largest estuary in the United States. It is made up of over 150 rivers and streams, and it covers over 64,000 miles. Even though it only borders Maryland and Virginia, the watersheds span way into Delaware, New York, Pennsylvania, and West Virginia. The bay alone is home to over 250 different species of fish, 300 migratory birds at any time of the year. It also contains a variety of aquatic grasses and several species of mollusks that help filter the water in the bay that a lot of people use actually as their drinking water nearby. It also has a huge impact on the local tourism in that area, since a lot of the people in DC are looking for a quick one-day trip to get away. They often go to different towns along the eastern shore to go kayaking, hiking, sailboating, and all that. It also provides a lot of jobs in the area due to fishing, since a lot of people in those areas are fishermen that make about $20,000 to $30,000 a year. And throughout the Chesapeake Bay, roughly it's estimated that around 200 islands have already disappeared into the bay due to sea level rise and erosion. Due to the conditions of the bay, sea level rise in that area is actually about twice the average that it is in other areas due to land sublimation and the island sinking into the bay. And then Smith Island is the island my project is on. It's a very small island that is located in the Chesapeake Bay, kind of out in the middle of it. As you can see, it is also the only inhabited island in Maryland that's not connected to land by any bridge. You have to take a ferry to get there. And the ferry sometimes only operates one time a day. And throughout maybe the summer, it operates a few more times. The schedules are all over the place. And then actually, once you reach a certain grade in school, you have to take a ferry about 10 miles to the nearest mainland school to go to school. And the island has about 300 year-round residents that live between the three towns mentioned there, Ewell, Rhodes Point, and Tylerton. During the summer, more people live there, but I just don't want the year-round number since it can fluctuate. And then the upper portion of the island that's circled is actually a national wildlife refuge that's ran by the U.S. Fish and Wildlife Service. And then the island itself, due to its location in the bay, helps protect other islands further up in the bay and the shoreline of the mainland from damage from the waves that are coming into the bay from the ocean. And it helps lessen a lot of the damage there and erosion to the other islands. And some of the sensitive species that are on the island, it's important to cover that because the entire island itself is designated as a sensitive species project area by the state of Maryland, meaning that it contains a rare, threatened, or endangered species in an ecosystem that is of high value if it is lost. Since the entire island is mostly a brackish marsh, it's a hard ecosystem to replicate anywhere else. So there are a lot of species such as the northern diamondback terrapin that are only found in a few places on the East Coast that call that island home. And they're currently designated as a special interest species by the U.S. Fish and Wildlife Service, and then several states, including Maryland, Virginia, and Connecticut. And they're suffering a lot of habitat loss, so their populations are decreasing because they're having to travel further between islands to go lay their eggs, and they're running into more like human risks, such as boats and stuff like that can kill them. And there are 4 additional species of birds that reside on the island. They're also on the focus species list. The American oyster catcher, seaside sparrow, surf scoter, and the clapper rail. And then there's some pictures of them. And why are we so worried about the island? Due to sea level rise and erosion, the island is predicted to be almost entirely underwater in about 80 years, if no mitigation or restoration projects take place within that time. Currently, I believe the Army Corps of Engineers are trying to get funding for a project nearby, but every year it seems to get pushed back, so no real progress has taken place on that to try and dredge out some of the areas around the island and use that to pump back in. And if the island does disappear, that could result in about 300 residents being displaced. And as I said, this area, most residents are either retired or they only make about $20,000 to $30,000 a year. Maryland's a pretty high cost of living state, so the idea of them just getting up one day and moving to purchase a house in Maryland isn't that realistic. And there has been offers from FEMA to buy out residents' houses on the island, but for the cost of the house, they can't really afford to move to the mainland. Also, some of them have family dating back to the 1600s on the island, so they're not really looking to move. They're pretty attached to the island. And as the island gets destroyed, so do all those valuable ecosystems. So we're also at risk of losing a lot of sensitive animals there as the island erodes away. So the objectives of my project are to understand the overall impact of sea level rise and erosion on Smith Island. And to do that, I'm going to explore the impact sea level rise will have on Smith Island and the community and their access to essential needs. When I say essential needs, I'm mostly referring to shelter, their access to purchase food, and emergency services. And the second objective under that would be to evaluate the impact of sea level rise on vegetation and wildlife habitats and the potential for enrichment on developed areas, because as the marshes disappear, the animals will have to move closer to those developed areas. And the imagery I plan on using is the imagery from the 2021 National Agricultural Imagery Program from the USDA, and then Landsat imagery from 1973 until this year. So I'll be using data from Landsat 1 all the way to Landsat 9, like most likely. And then the first step in my methodology is to build a geodatabase of the entire island. It's not very large. The portion people live on is only about 9 square miles. So I'm going to try and build it with all of the roads on the island because there's only a few, and then every single structure on the island. And they'll be broken down into the categories of residential, a retail establishment, so a bed and breakfast, or a place you would purchase food or souvenirs. Manufacturing, because there are a few businesses on the island, such as a coffee bean processing company, emergency services, so your fire department, things like that. There are 2 post offices on the island, so those will be included, the 1 schoolhouse, any religious establishments, and then I plan to include the boating docks, since many of them are for employment and transportation on and off the island. The next step will be using the geodatabase I created along with sea level rise layers from the National Oceanic and Atmospheric Administration to determine which roadways and structures will be impacted by sea level rise. I'm going to do 2 assessments for the year 2050 and 2100 to decide what levels of sea level rise will happen by that year. I'm going to use projected values from the state of Maryland. They require the University of Maryland to do a 5-year study on science-based projections for sea level rise. The last one was in 2018, so it might change this year. And if it does, I'll use those values. They have an average projection, which is usually a range of like 0.8 to 1.2 feet. I'd likely go with the middle value of 1 foot, just so I'm not swaying to one end of that range. And then I'll do the worst case projected value for that year of 2.3 feet. And then the same process will be used for the year 2100. And to the right is just an example of what 1 foot of sea level rise would look like over a digital elevation model of the island. As you can see, all those blue areas previously were land, and they are now underwater. And then just to get an idea of how much animal habitat has been lost over the last 50 years, I plan to use Landsat imagery from 1973 until 2023. I likely will have to modify some of the images. As you can see, the one on the left is very dark. It's from 1973. It's a Landsat 1 image. And then the one in the middle, I believe, is 2003 and then 2013. So they'll lead to modification. And I plan to do this by using classification of what is land and what is not land. Due to the quality images, that might not end up being the best method. And if it comes out, I don't feel that it's correct, I'll likely do it manually by outlining those. And then the next step there are several layers. One is for the terrapins that I showed you earlier. There's a waterfowl layer, and then one identifying sensitive species sites. I'll likely use all of those along with the predicted sea level rise layers to get a better understanding of how much of their habitats are at risk. To the right here, everything outlined in green was identified as a terrapin habitat. And as you can see, with 1 foot of sea level rise, a very large portion of those are already gone and will only get worse as the sea level rise gets higher. And all of those layers are coming from the Maryland Department of Natural Resources. And the final portion of my methodology will be using layers from, once again, the National Oceanic Atmospheric Administration that are representing marsh migration with each foot of sea level rise. The image here on the left is the current state of the island, where a lot of it is identified as a brackish marsh, with the 3 colors I have down there being developed spaces of different types. With 1 to 2 feet, you can see a lot of that starts to disappear, and the only marshes are soon to be near the developed areas, which will result in a lot of their habitats blending together, once again, endangering the animals. And then my anticipated results, it's going to be a lot of maps, maps identifying the areas where the residents may no longer have access to their essential needs and may need to locate to another portion of the island or move completely. And then other maps showing the potential changes in habitat and where they could overlap with developed portions of the island, making it even harder for the animals to exist on that island. I think the value of this presentation will be to bring attention to Smith Island and the issues the residents and wildlife will face there in the next 80 years if no action is taken, and to bring attention to the impacts and the importance of sea level rise and erosion on an area that's often overlooked due to its size, population, the modest per capita income, and the lack of tourism. Just today, I was talking to my coworker about my project, and they didn't know this island existed. They were asking me what country it was in, and they were completely mind blown. And I was like, oh, it's 2 hours away. And then again, just raise awareness for the island and the need for these mitigation and preservation projects to preserve the island, because a lot of the federal funding also requires like a private company or organization to step in and provide some of the funding, but it's not a known issue, so that really hasn't happened much. And then the proposed venue for my presentation is the American Association of Geographers annual meeting in April of 2024. They don't have their submission deadlines for next year's meeting, so I just based my timeline off of the submissions from this year's meeting, which was the abstracts are due in November, and February is the deadline to edit those. Here's my proposed timeline. I'm sure it won't go as planned, but in July and August, I plan to create my database and begin my assessments for the sea level rise on the residents' needs. And then through September and October, focus more on the wildlife portion of that and have my abstract submitted and my draft paper submitted in November, and then make final edits and present by April 2024. Plan to take 596B in the spring 2 semester of next year. And here are the links to my data, and then these are my references. Oh, sorry, I just saw your question. Have you thought about change detection maps as one of your maps? Possibly for the Landsat imagery where the island is shrinking. I think that would be a good idea to get a better idea of how much is going down in 10-year increments.
All right, Marissa, thank you for your presentation. I lived in Baltimore for a little while, so I'm familiar with Smith Island. Maryland resident. One question I have for you, I'm going to play the devil's advocate here for just a minute. How much remediation would be required to keep that island in some functional state that the residents wouldn't have to leave?
True. Well, that's hard to say. I know nearby islands, I believe Swan Island, which is to, I think, the northwest of this island, the Army Corps of Engineers did like a dredging project where they kind of rebuilt the island with sediment they pulled out of the bay. And so far that has helped keep the island together and keep the habitats all together. I'm not sure how much of that would take to preserve this island. It was pretty expensive, and it would probably be expensive to do it again. And we don't know how long it would last. So unfortunately, that is kind of I don't really know the answer to that question, so I don't think there really is a good answer to that question. Because
yeah, it's one of those. Yeah, what Yeah, what can you do to mitigate the loss or at least prolong it?
Yeah, and then I guess pulling the drinking water from the bay has also increased some of the erosion of the islands because it's the sucking of the water is kind of pulling everything into the bay too. So
Right. Yeah.
do we just not drink water? That's kind of a hard question. And then I have one question for you as a Maryland resident. Have you had Smith Island cake?
No, I haven't.
You should. It's amazing. It's the state cake of Maryland. And one more question was, how does has natural disasters affected Smith Island versus rain? Whenever it storms or there's a hurricane out of the area and there's like a storm surge or coastal flooding, it tends to flood the island a lot more. And then like as it washes away, it pulls more sediment away with it. So when it does storm and flood there, it tends to damage some stuff. And recently, I believe they were just hit by a tornado and they were hit by a hurricane about 10 years ago, and that affected them pretty badly. Have I mapped before or after 2022? I have pulled imagery for this year because I'm trying to stick to 1973 to the present year. But I haven't created any maps yet, as pulling imagery of the island took me a good bit since they usually break it into pieces. And then the next question was, how will you determine areas where residents no longer have access to services? Will you employ network analysts to determine the areas on the island are no longer accessible under very sea level rise conditions? For that one, I'm probably not putting the best scientific method there, but I do have a digital elevation model of the island as it currently is, and then sea level rise depths. So let's just say there's a house and the sea level rise makes it a foot below water. I'm just going to say that that house is no longer accessible to that resident since they most likely cannot live there. And then once those docks are underwater, those are once again most likely not accessible to the residents. So I'm just going to identify those as most likely unaccessible. Same thing with any of the other structures that are on the island.
Does anyone else have questions for Marissa? All right, Marissa, if you could include your contact info in the chat window in case someone wants to follow up with you, that'd be great.
Okay, sounds good. And thank you so much for your time.
Thank you. Next up, we have Miranda Waldman. Miranda, if you want to start sharing your screen.
Hey. Screen.
Very good.
Okay. Well, thanks everyone for taking the time to listen to my capstone proposal presentation tonight. My project is on shooting range remediation, and it uses kriging to delineate the extent of lead contamination in soil from an uneven sampling pattern. So I'm going to start with the study area. The study area for this analysis is a sporting clay shooting range and the immediate surrounding areas in Southwest Pennsylvania. It is approximately 275 acres in size. The shotguns that are used for sporting clay courses typically contain shot with hundreds of tiny lead balls, which when shot at disperse in the air to create multiple projectiles. This data comes from my place of employment, and to keep client privacy, I'm required to keep the exact location of the site anonymous. The main data set that will be used is a set of 442 points that represent soil sample locations. The distribution of these sample locations is not even across the extent of the study area. You can see in the map of the samples that there are big gaps in the middle of the data set. Most of the samples were collected following a 100-foot grid pattern, but many of them did not follow this pattern, especially on the shooting range itself. One reason for this is that the property owner is less interested in the remediation of their own property, but more interested in, on the offsite properties that they have contaminated. All of the samples were collected between 2019 and 2022, and they were collected between 0 to 6 inches below the ground surface. There are 2 goals for this project. We need to define the extent of contamination, but the challenge is that lead values are only known for a limited number of sample points within the study site. To determine extent, we first need to generate a surface of lead levels for the site as a whole, which requires spatial interpolation. The delineation will be to 450 milligrams per kilogram, which is the Pennsylvania Department of Environmental Protection, or the PIDEP's, statewide health standard for medium specific concentrations of inorganic regulated substances for the direct contact value of soil for lead. It's a mouthful. Because several methods exist to spatially interpolate data, different kriging approaches will be examined to determine the approach that best reflects the underlying spatial structure and results in minimal estimation error. The anticipated results of this analysis are the predicted lead surface for each kriging method and the accompanying error surface. The image on this slide shows an example of a prediction surface and its accompanying lead surface. Next, I'm going to go into the background of my study. Lead levels in soil have been increasing due to human activity for decades. This is a growing concern as high lead levels lead to many adverse health effects, with almost every organ and system in the human body being affected by high levels. When lead gets into soil, it does not break down, so it stays there. It can impact humans in a couple of ways. For example, food grown in lead-contaminated soil makes the food itself toxic as well. And for children especially, playing or touching bare contaminated soil can lead to exposure to lead. Shooting ranges are one source of large lead accumulations in the environment. The picture shown on the screen is an example of what the lead shot can look like in the soil at a shooting range. Up until 1993, there was very little regulation on shooting ranges from the federal government. That changed when a U.S. Court of Appeals ruled that soil contaminated by lead shot could be considered hazardous waste if unclaimed. Because of this, most shooting ranges have adopted lead management plans. This usually involves preventing lead from getting into or migrating within soil. But in cases where lead is present in the soil, it is necessary to treat it to prevent further spread. This is where environmental remediation comes in. And for this case, environmental remediation involves the removal or minimization of the lead hazard. This is often very expensive, and costs can easily increase drastically at large sites, especially if the scope of the work changes. Because of this, it is crucial to characterize the extent of lead contamination as accurately as possible. This usually involves taking samples and submitting them to laboratories to determine the level of the contaminant of concern at that sample location. These samples are not a continuous representation of the contamination, though, and that's where the interpolation methods are often utilized. I also want to point out the image on the slide, which is an example of what it may look like, and it does look like at this site, taking these soil samples. A hand auger is usually used, and that's pretty typical for samples that are only to 6 inches. IDW is one common and widely used spatial interpolation method. It is a deterministic method, which means that the data points being input are exact, and a deterministic mathematical equation is used to carry out the interpolation. IDW assumes that the influence of a sample point on the estimate of an unknown location declines with distance, and this distance-based relationship is controlled by the selection of a single parameter. This is in contrast with kriging, which is another widely used interpolation method that is a common approach in soil, geology, and environmental science applications. It is a stochastic interpolation method, which considers the spatial dependence between points. A key difference between kriging and IDW is that kriging honors the underlying structure of the sample data by fitting a semi-variogram model. Estimates at unknown locations are based on the semi-variogram describing the spatial structure of the data and the spatial arrangement of the sample points. A second benefit of kriging is that because a model is fit to describe spatial dependence in data, kriging can quantify the uncertainty in the predicted value and returns not just the predicted surface, but also a measure of accuracy of the predicted surface. The maps on the screen show an example of data that has been spatially interpolated using IDW, which is on the left, and ordinary kriging, which is on the right. Kriging is a multi-step process. When using kriging, first you create a variogram, which describes the spatial dependence of the variable of interest. Then a mathematical equation is fit to the data in order to summarize this variation in the data. And last, sorry about that. And last, the model and consideration with the spatial arrangement of the sample points in the local neighborhood is used to determine the interpolation weights. The result of this is an interpolated surface and the means to estimate prediction error. There are many variations of kriging, which reflect differences in the assumptions made with regards to the underlying surface. Many different types of kriging have been used for lead in soil, including block kriging, simple kriging, ordinary kriging, and kriging with external drift. The images on the slide show steps from the block kriging method used by Alexander. The variogram and fitted model are on the left chart, and the interpolated surface is on the right map. My methodology will employ ordinary kriging, one of the most commonly used kriging approaches. Ordinary kriging uses the sample points that fall within the local neighborhood to estimate the mean used in the kriging equation. It is less restrictive than simple kriging, which assumes the mean is known exactly. Kriging with external drift is another common method that uses ordinary kriging combined with an underlying trend modeled using a secondary variable that is found to be correlated to the data. In the case of lead levels, topography has been found to influence lead levels, and this trend can be incorporated using kriging with an external drift. To start my methodology section, I'm next going to go over the statistical analysis that was done to assist in the formation of the proposed methodology. To determine if kriging is suitable for this data set, I conducted a statistical analysis. I asked two questions: is the data distribution normal, and is there spatial autocorrelation present? To start, I made a histogram with the lead result values to see if this data was normally distributed, and this is the result. The lead values are shown on the x-axis, and the count of samples in each bin is shown on the y-axis. This graph shows that the data is not normally distributed, but skewed to the right. This is a common occurrence in environmental data, which often conforms to a log distribution because it is bounded at 0, meaning there will be no negative values, and tends to be positively skewed like we see in this graph. Because of this, I log transformed the data to see if it would then follow a normal distribution. And this is the histogram of the lead data after it was log transformed. This graph shows that the data now follows a much more normal distribution. It is much less skewed and better approximates a normal curve. Next, I calculated the global Moran's I value using ArcGIS Pro. This was done to get an idea for what the spatial autocorrelation is between the soil samples. The default values were used with the exception of the distance band. This was set to 150 feet because the majority of the samples were collected on a 100-foot grid, and the value of 150 encompasses the diagonal distances between these sample locations. The resulting value was 0.398802. This shows that the log transform dataset has positive spatial autocorrelation in lead values for this dataset and confirms the suitability of spatial interpolation in this study. From this result, it was determined that all kriging methods will be carried out using the log transformed data. Next, I'm going to talk about the methods I will be using to complete the rest of this project. 3 kriging models will be examined to account for the gap in the sample data at the center of the site. Method 1 will assume that the spatial structure estimated using all samples applies uniformly across the study area, including the gap. One semi-variogram model will be fit using all the sample points, and ordinary kriging will be used to create an estimated lead surface. Method 2 will assume that the spatial structure varies across the study area, including within the gap. The study area will then be broken into sections, each covering a sampled area. Individual semi-variogram models will be fit using the sample location in each section. Ordinary kriging will be employed in each section, resulting in multiple interpolated surfaces. Previous research has suggested a possible relationship between elevation and lead levels. This relationship can be incorporated with an external drift, which is the third model I will examine. In this kriging method, a trend surfaced based on elevation would be incorporated into the prediction. Given the topography of the site, which is shown on the map on the screen, the observed relationship between lead levels and elevation will be used to update ordinary kriging estimates. To determine that kriging with external drift is a suitable method to interpolate the data, an exploration of the relationship between lead levels and elevation will be quantified. The final piece of this analysis will be to compare the interpolated surfaces. The RMSE and overall distribution of errors across the methods will be evaluated, and the final calculated remediation areas will be the final areas of the calculated remediation areas will be considered. I plan to work on the bulk of my analysis during the fall 2023 and spring 2024 semesters. I also plan to take the next capstone class in spring 1 of 2024. I have 3 conferences I am interested in for next spring. The first is the National Association of Environmental Professionals annual conference, which will take place in early May, the Association for Environmental Health and Science Foundation West Coast Conference, which takes place in late March, or the PAGIS conference, which takes place in early April. The reason I haven't selected one from that list yet is because they have not yet released the topics for which they want to see for the conference. I'm assuming for the first 2 that they'll be pretty similar because those conferences attract a lot of people who work in environmental consulting like I do. But the PAGIS conference, I'm not entirely sure yet. So for the possible presentation value, numerous stakeholders can benefit from this research. The surrounding property owners affected by this shooting range will greatly benefit from having an accurate delineation of the extent of contamination on their properties. My colleagues and other environmental consultants will benefit from the potential for time and money savings from a better understanding of the choices made to define lead contamination. Scientists can also benefit because there will be an additional kriging methodology for uneven sample distributions of lead to reference when they're coming up with their own studies. I myself will also greatly benefit from this project. As an environmental consultant, I will have work that is much more defendable, and I will have greater knowledge of how to solve this common problem. It will help me move forward in my career by increasing my credibility, knowledge, and competence. And that's everything for my presentation. Does anybody have any questions?
All right, thank you very much, Miranda. That was a very interesting presentation.
Thank you.
Looks like you have a question in the chat window.
Yes. So the question is, how do you think property owners will react to your results? Do you think it will be easy to explain this to them? That's a great question. The property owners already know. I can't share too much information right now. This project, the client will eventually be public. They're just not yet. But the property owners, they're the reason this work is happening. Let's just put it that way. So they are a part of this. Have you seen, the next question is, have you seen if there is any prevailing winds that had any effect on your lead distribution? No, we have not looked into that. But that's definitely something that is worth considering.
One question I had was, so you had, if I understand correctly, three different approaches that you're going to look at, because obviously your sample points aren't in a single location. You've got that big hole in the middle where there are no sample points. So you break the study area up into different parts, or so you're taking different approaches, which is fine. But I guess my one question is, how are you going to, or have you thought about how are you going to make a single visualization of the lead surface for the area, or is that not really your goal?
So I think, if I'm understanding your question correctly, the goal is to see which one, to evaluate the error for each method and to see which one works best for the data. So I guess the goal isn't for all three surfaces to be combined. It's to figure out, in combination with the error and also the total area of remediation area based on that 450 milligram per kilogram value. Which one, right now we're thinking that we'd want to select the method, or weight the selection of the method based on what area has the most. And Amy's added that the goal is to quantify area to be removed and less to map the site comprehensively. Yeah.
So that 450, that's kind of your standard by which you're basing I guess the remediation or non-remediation of the soil in that area.
Yes. Yes.
Is that an accurate?
Yeah. So 450 is what what the state of Pennsylvania has determined for this case, or not just this case, but what we're using for this case is clean, or something, or better accurately, will not have adverse effects to people.
Right. So anything less than 450 is okay.
Yeah.
And then
we don't have to get rid.
Yeah, right. Anything over 450 should get removed or fixed or whatever.
Exactly.
Okay. All right. I just want to make sure I was clear in understanding that. All right. Does anyone else have questions for Miranda? Miranda, yeah, if you want to put your contact info in the chat, so if someone wants to follow up afterward, that'd be great.
Okay, great. And I'll stop sharing my screen.
Okay, thanks again.
Thank you.
Nicholas Murray, I think, is up next. Nick, if you want to start sharing your screen.
Hello, can everyone hear me all right?
Yes.
All right.
All right. Yep, we see your screen. So yeah, whenever you're ready, you can start.
Good evening, everyone. Like previous presenters have said, thank you for your time and attendance, for being present for my capstone proposal presentation. And my presentation will be a proximity analysis of industry siting and income inequality in Pennsylvania. To start off with the general background, NIMBY or NIMBYism, acronym for Not in My Backyard, represents communal rejection of a variety of developments. These include waste disposal facilities, landfills, anywhere from industry incinerators to even communal services such as homeless shelters or planned low-income housing developments. My focus is going to be on industry surrounding electricity generation, and that will be a separation between fossil fuel burning electricity generation industry and all types that I'll show later in my data that I've gathered. The effective NIMBY also has a variety of history of research on its impacts. However, the overall movement of successful NIMBY propositions and their proceedings have been simply relocating planned developments into other communities, in the essence that a successful NIMBY proposition simply starts the process of the siting in another location. Not that it's a closed proposition in its entirety. NIMBY and NIMBYism was recently ranked as the second largest barrier to construction, second to rising costs of construction and materials. And the effect of NIMBYism on its impacts on the location of the fossil fuel industry is recognized by the US EPA's Environmental Equity Work Group. The graph on the right is from the Clean Air Marks Division of the EPA, and it represents, I believe, a 3-mile radius of fossil fuel power plants in proximity to the following demographics above an 80th percentile. These are not exclusive to each other, and the fossil fuel electricity generation sites specifically represent several emissions concerning to overall air quality on a daily basis. Some of these include sulfur dioxide, nitrogen oxides, particulate matter, and carbon dioxide. This can also include mercury and some other pollutants, but the general concern for the proximity of neighborhoods and neighborhood air quality on a daily basis is these emissions impacts on the formation of ozone, fine particulate matter, poor air quality or air quality warnings in certain neighborhoods such as Pittsburgh, and its impacts on the development of respiratory or cardiovascular problems. And this has been shown to already be at a higher rate in low-income communities. And overall, my study is going to investigate whether or not there's a proximity correlation between electric generation industry siting overall and specifically fossil fuel industry siting in proximity to communities of low income. Next, because these the previous listed health impacts and air emissions, the air emissions specifically have been shown to been acutely impact and bring up both emergency asthma events and simply increasing the rate of cardiovascular or asthma related health events at all ages, but specifically at a higher rate in children. And whether or not air emissions from fossil fuel electric generation sites are in proximity to a low income community, it can become a positive reinforcement cycle and further promote these negative health impacts surrounding the air quality, in addition to the effects of low income on these health impacts. However, this has been discussed and researched surrounding environmental justice and whether or not there's environmental equity in all communities surrounding proximity to polluting sources and air quality concerns, whether or not those are a burden for all Americans or for certain communities. While air pollution and these effects of these pollutants have been reduced over the past decades, and it is expected to also continue moving forward, but whether or not the siting itself is going to change is going to only time will tell for that. Overall, I am going to look into an overall discussion for a hard manpower and financial cost of starting and successfully implementing NIMBY movements in a successful proceeding. Looking to whether or not there are more specific costs researched for a successful NIMBY proceeding, specifically against industry, such as the sites I'll be bringing up, and whether or not the study area of the fall of several urban counties in Pennsylvania have any specific history of zoning laws or a history of laws that would impact the siting of the sites that I'll be researching and skew any proximity analysis. I will eventually run separate analyses between all sites in general and fossil fuel specific electricity generation sites to see if there is a difference between these industries in general and the fossil fuel industry, and whether or not there is in fact the anticipated proximity correlation between industry siting, if not specifically fossil fuel industry siting, and communities of lower income. The specific study areas for both the communities and the industry sites will be Allegheny County, home to the city of Pittsburgh, Philadelphia County, the city of Philadelphia, and Dauphin County, the city of Harrisburg. I have 3 slides showing the county preparation as well as the point sites of recorded electricity generation industries and their source of fuel. And then the highest density of these sites is going to be in Philadelphia County, and the specific buffer that I'll be using to how far away these sites will be included per census tract is going to be in a final determination with my advisor and I. The EPA in the past has used 3 miles, but when there's specific concerns about air quality. 3 miles is not a barrier for some air emissions to impact the community and their air quality readings. So far, I have the electricity, the e-grid, electric power generation facilities data from the EPA, with mainly the discrepancy of which fuel source for each electricity generation site, which I will be able to classify and separate. And the American Community Survey estimates for median household income per census tract for all 3 counties. And one of the concerns is the accuracy of the ACS income due to the amount of different data sets for each year, and then the difference between the 1 and the 5 year estimates, and the somewhat large rooms for air per county based on the year. For my proposed analysis, I will be performing a linear regression to map residuals per census tract, using the income from the Census Bureau ACS estimated household income, and then the distance measured as proximity for each industry site. Because I am only at the moment proposing the state 3 counties within the state of Pennsylvania, it is isolating urban versus rural counties. It is limited to the state of Pennsylvania, and whether or not there may be differences from state to state, the impacts if this was instead run on, ideally all counties within the United States with specific cities throughout all 50 states. And the limit of the amount of sites in some counties, such as Dauphin County, may only have a handful of industry sites to run for this analysis. And whether or not there should be more than 3 counties, whether or not there should be more than urban counties included. Overall, I do believe through the advancement of environmental justice and this analysis bringing up the discussion of where in the past, and then what plan developments are in the future, where are these sites succeeding in their zoning and their hearings for whether or not development is passing, why certain communities are avoided. I believe the threat of certain NIMBY proceedings for certain communities are a factor, and overall the advancement of environmental equity, and whether or not certain polluting sites are located as an equal burden, and whether or not that's an equitable distribution for all Americans and not specifically certain communities. I am anticipating that the renewable industry would have less pushback from environmental NIMBYism, and I anticipate fossil fuel and industry sites associated with pollution to be more aligned to proximity with lower income communities. I plan to take 596B in fall 1 of next semester, and I will be doing the majority of this research and gathering of my final presentation throughout the summer and fall of this year. And I want to say thank you, and that's all that I have for this presentation right now.
All right, thank you very much, Nick, for your presentation. Looks like you have a couple of questions in the chat window.
Yes. I see a selection of evaluation. What definition of urban are you using? Through discussion with my advisor for this study being, it originated with Allegheny County. However, the concentration of running that study solely on Allegheny County in the city of Pittsburgh, I felt it was an agreement that it'd benefit being expanded. And for the state of Pennsylvania, I simply classified that those counties as urban for having, 3 of the main cities in the state, the capital, and then Philadelphia and Pittsburgh. All right, and then following on the next question that you have, Bertram, you need space for power generation sites. So with your selections, how do you justify the impact to people in Northwest Philadelphia? That is a concern with, my classification of the 3 counties as urban, that the distribution of land use can vary from, certain counties in Pennsylvania, let alone certain states throughout the country, and whether or not there is simply enough space in certain cities for, industry sites to be, in development, and whether or not, just for example, in Philadelphia, whether or not it's there's enough, space left for urban site development that certain communities would still be considered lacking environmental justice and low income, but not, they could influence the analysis because they aren't in proximity to industry. I do believe that there's also a factor of history with some cities, and some, whether or not some sites are still active, whether or not they're planned to be retired, and that'll be included in my research. And this is also going to be an analysis on the existing infrastructure of these sites, and some of them are decades old, and including in Philadelphia. And then Amy, I have explored the EPA's EJ screen tool, and I'm familiar with that. As a MGIS capstone, I did want to highlight the majority of mapping and my analysis. I wanted to focus on that being within ArcGIS Pro, but I do have a background in environmental science, and I've been exposed to that tool in the past.
One quick question here. I may have missed this, but you did allude to it in one of your responses. Have you, or are you going to consider incorporating land cover, land classification data into your analysis?
Such as, or like the proximity of urban green space and zoning, in addition to where these industries are sited?
Well, yeah, I mean, if you're looking for, new places to build, or how to classify existing land cover for purposes of zoning or whatever, yeah. So those kind of considerations.
I do think that that's related to the overall theme of the presentation, and around what hazards are inequitable in proximity to lower income communities. But at present, I did not plan on incorporating zoning, the allocation of zoning history or existing land use classifications for these counties.
All right. Does anyone else have any questions for Nick? All right. Oh, there's another one.
Bertram has another question. I'm sure you can see it on the screen if it's showing. I have the chat open. I'm not sure which window it's showing on the screen share, but Bertram asked that he loves the topic, being a resident of Philadelphia, and the PSU extension as an urban agriculture education specialist. One of the cities that is hit hardest is Chester, not in Philly. I think that there's a lot of cities brought up in this topic all over the country, if not globally. I'm a current resident of Pittsburgh, and have worked in and around and researching the air quality history and current air quality measurements, yearly in the Allegheny County, and that's where I'm a current resident. So that's why my original county was out, just singling out Allegheny County and looking at the history and current distribution of those sites. And I could, I look forward to following up with anyone's for specific advancements of this moving forward. And at present, I am available with extending the scope of my current study sites to additional cities or counties, either within the state of Pennsylvania or within the region.
All right, Nick, thanks again for your presentation. If you could put your contact info in the chat, someone can follow up with you at a later date. That'd be great.
All right, I'll enter that now in the chat.
Then if you can stop sharing your screen, we'll get the next presenter lined up. Thank you very much. Next up, we have Jared DeMall.
Hey, how are you? Are you reading me okay?
We hear you loud and clear.
Awesome. And can you see everything?
We see your PowerPoint.
Terrific. All right.
So whenever you're ready, go ahead.
Fantastic. My project is back to air mobility and the future. You're currently living in southern.
Jared, you're fading in and out quite a bit.
I'm sorry. Can you hear me?
That's better, yes.
Okay. Right now I'm living in southern Illinois, just outside.
No, we've lost you now.
Oh man.
You are offline. Well, so that's a good question. Can we skip ahead? I don't think we can, because the next presenter isn't slated to present until 8:30. And I've tried to send her an email asking her to join early. And I haven't had a response yet. So that may be maybe problematic to skip ahead to the next presenter. Yeah, take 5 minutes, that's fine.
All right, I'm back. Are you still reading me?
Yep, so far.
Hopefully it's a little it's a little better. I had to switch computers.
Well, your voice sounds better than it did. So hopefully
Terrific.
that's a good sign.
Awesome. Okay, I'll go ahead and start sharing my presentation, and I'll just kick it off. All right. So once again, using AI and GeoInt to protect air mobility in the future battle space. I'm Jared Damali. Right now, I'm living in Southern Illinois, just outside of St. Louis, where I work as an intelligence officer for the Air Force. I work in the Air Mobility Command headquarters, which is the military's airborne logistics force. So in short, we are the ones who own the big cargo planes that move a lot of things and people. This capstone hits close to home, particularly for me, because as our defense strategy shifts, so does the Air Forces. And our military leaders are at the stage right now where they're looking for new innovative solutions to problems that are presenting themselves with this shift. And this capstone is sort of my answer to the current problems that we're facing with mobility missions. So let's talk about doctrine for a second, just to get some background. Between 2002 and 2021, the US military was embroiled in the global war on terror. A few years ago, it became apparent that the pace at which we funded that campaign with both human and financial capital was unsustainable. So we began to sunset through a series of drawdowns and turnovers until it was finally declared over in August of 2021. But we still maintain a presence in a peacekeeping capacity in a lot of those countries. However, in 2018, the new US defense strategy was published, and it put peer adversaries on the radar, and we started pivoting away from unconventional insurgencies in the Middle East. During the time that we were active in the Middle East, countries like Russia and China had already begun projecting modern military power onto smaller nations in a series of territorial disputes that are still ongoing today. You can see them in the news. And what this meant is that we needed to adjust the pace and the weight of which we prepared for what could be the next conflict. We could no longer really be afforded the luxuries of surplus funding, real estate, people, or equipment, and the military was encouraged by Congress to lean out its requirements and find ways to become more agile without sacrificing any of its capabilities. So the Air Force came up with what is called the Agile Combat Employment, or ACE concept. It's a new doctrine that favors a thinner, more flexible force that can be maneuvered and projected across large expanses. It's focused primarily on joint military agility, and it most definitely cannot happen without execution from mobility air forces that provide the logistic enabling for ACE. It's an undertaking like this requires a completely new approach to logistics, which means that in order to accomplish this task, mobility air forces need to adjust their posture equally. And this new posture that they've adopted is called rapid mobility. And if you look at the graphic there, this is a real, like a way scaled down version of what ACE is supposed to look like. And you can see how mobility forces, rapid mobility there in the middle, are essential to the equation by moving resources from support to operating locations. So I'm going to go ahead and backburner that for a minute and talk about GeoInt. So just to get everyone spun up as well, GeoInt is the long established marriage of geography and intelligence analysis. They always say everything happens somewhere. The pace of GeoInt has been changing and evolving for the past 20 to 30 years with the introduction of new technologies, computers, GIS, global positioning, satellite constellations, and now we have artificial intelligence on the forefront. Historically, GeoInt was mostly the exploitation of an analysis of imagery that was taken from planes and satellites. And nowadays there's a whole subdiscipline that centers around deriving conclusions from imagery. But as technology progressed, we were able to marry in things like geolocation, near real-time and persistent watch capabilities from drones and satellites, and improved temporal analysis where we could look at historic data that's affixed to a certain position. So today's definition of GeoInt has expanded to include the array of tools and analysis that's used to build that kind of domain awareness, which empowers decision makers with social, environmental, economic, and geopolitical knowledge. So today it's now so much more than just imagery. So my capstone is aimed primarily at the American warfighter. So I'll explain how today's military fields GEOINT in the battlefield, especially at the most baseline level. GEOINT is classified information. It's secret and top secret information. And in the field, a GEOINT analyst requires access to multiple networks, computer networks, to receive and or send sensitive GEOINT information. They also need special equipment to properly store, protect, and dispose of that GEOINT information. And lastly, they need special facilities to be built that can protect the equipment and sensitive information as well. And mind you, that's only the resource side of the coin. It doesn't really include the IT personnel, the analysts themselves, the contracts, and the computer programs and everything that's needed to run a successful GEOINT operation. In that picture, that is probably the most baseline GEOINT setup that I've seen in a wartime theater. And to be totally frank with you, it's slow. It only has basic programs. It's susceptible to the elements overheating, and it will almost certainly fall into disrepair sooner than later. And during the global war on terror, the U.S. really spared no expense putting its GEOINT specialists in the field. We saw strides being made in the geospatial sectors, both commercial and military. And we enjoyed the privilege of being able to deploy mass amounts of equipment and manpower to the forward line, where we fought an unconventional enemy that really did little to disrupt the intelligence footprint that we had in the Middle East. So in summary, today's expeditionary setup for conducting GEOINT, it requires a lot of people, equipment, and facilities to protect those networks that are used to pass the information. Now, as for the Air Force, in the sake of this project, GEOINT is going to be defined as mostly identifying locations and capabilities of threats to actual air operations. Our primary focus are things like surface-to-air missiles and anti-aircraft artillery that are possessed by adversary nations. GEOINT for the Air Force it generally encompasses anything ranging from those threat ranges to something like policies that could potentially drive the intent to strike aircraft while they're flying. So bringing doctrine back into the picture as well and combining GEOINT and ACE, what does the ACE concept require of GEOINT moving forward into the new battlefield? The ACE doctrine has met its fair share of challenges. The military largely became accustomed to a certain type of operation for 2 decades, and now our leadership is asking us to do a complete 180 on what we know. And everyone is affected by the changes, especially intelligence analysts. ACE requires a lot of new methods that will strip GEOINTers of the normal creature comforts that have been afforded during asymmetric conflict of the past 20 years and require them to do more with less. So first, it needs to be lean, but still be relevant. And the military can and will no longer afford risking agility by fielding more people and equipment than they actually need. Which brings me to the next point. It needs to accomplish that battle space awareness still. So despite the lack of people and equipment, the output from GEOINT analysts cannot suffer. The more the quality of the intelligence suffers, the more risk there is to people and equipment. And then third, it has to operate within an integrated contingency network or autonomously. And I really want to stress the autonomous part. Normally, information is passed hand to hand in the operational theater via email and other types of networks. But in the contested environment, classified communication is going to become a luxury. And the ways that an analyst acquires their information in the future needs to be less reliant on those classified networks. And the reason for this is that, our modern adversary is well equipped to disrupt, deny, or degrade communications between military elements, which means we need to be able to drive geospatial intelligence both online and offline. But therein lies our core problem. Today's geospatial methods are not conducive to tomorrow's battle. Agile capabilities come at a cost, and things like network reliant tools, equipment, and people become a liability in a degraded environment. And this is precisely what I'm hoping to address in my capstone project. using AI to compensate for the loss of equipment and personnel. In the most isolated environments, trained AI platforms like chatbots have the potential to become very reliable tools. So my goal for this project is to use an open source enabled AI to create a common operating picture, or a COP, if you hear me say that later on a mobile device that will empower mobility leaders with decision advantage and armed deployed analysts with theater intelligence capabilities. And I know that's a lot up front, but what that means is slimming down our known methods in tradecraft in a deployment theater. Why open sourced? Why deviate from classified information? In a contested environment, the luxury of access to classified information, like adversary threats and reporting, it won't be available all the time. It would really rely on the analyst to leverage their knowledge of threats and combine it with publicly available information like news sources to derive assessments that they could then present to someone like an aircraft commander. The common operating picture, or the COP, that I'm looking to create is it's just a military jargon for a type of GIS dashboard that we've all seen and are pretty familiar with. It would just use those AI inputs to create a GIS layer of threat information and populate that dashboard, which could then be conveyed to a decision maker. And why am I going with the common operating picture? The reason that I want to create the COP is because it's a proven concept that works for briefing airborne threats, especially to aircrew. It's widely available on phones, laptops, iPads, pretty much anything that's mobile. And a personal observation that I've made over the course of 6 deployments is that no one ever forgets their mobile devices. Those devices are capable of being able to communicate classified information. So it really can sidestep that issue. They're smaller, they're easier to use, because I mean, who's not familiar with a phone? And nowadays they're faster than the GEOINT equipment that I was talking about earlier. So why not take advantage of that and use those to monitor threat space during contingency? So how I'd like to do this is by utilizing AI to characterize an adversary order of battle and known operating locations. Characterizing an adversary, by definition, is really just the process of identifying and exploiting the locations, intentions, capabilities, and intents of your enemy. So for this step, I'd like to find and fix locations of adversary, people, and equipment that constitute a threat to a specific flying operation. It's undisputed right now that AI is also becoming the next step in technology. There are tons of debates going on right now about its security and its ability to evolve. And all in all, just the dreadful things that could occur were to fall in the wrong hands. However, to hamper AI's progress right now would be giving the upper hand to an adversary that is also choosing to capitalize on AI while we deliberate. Policy and ethics are going to be a huge part of the AI equation. And for this project, I'm only going to be utilizing a very elementary version of AI, a chatbot, really, something like ChatGPT. A chatbot is a computer program that uses AI to simulate human conversation. They can respond to user queries, carry out tasks, provide customer service, offer personalized recommendations based on user data and preferences. And for this project, I really want to rely on its ability to be trained and respond to user query, which I'll go over more on the next slide. That next bullet, importing battle space characterizations into the GIS platform. In short, that's just moving those AI generated outputs from whatever AI platform it's on to that common operating picture GIS dashboard that I'll be using. And then lastly, identifying threats to air operations at a specified location. The final output that I'm hoping to have is a simple spot on a map of a known adversary anti-aircraft system that can threaten a mobility operation, like plain and simple. And all of this, the big why, is to satisfy those ACE requirements, because conflicts of the future will be faster, leaner, lighter, and our ability to conduct threat analysis has to match that. So my approach From my experience, the scenario-based application generally proves as a good backdrop for a proof of concept. In this project, it's going to be an exercise essentially where I will be acting the part of a GeoInt analyst that's been tasked to a small military unit per an ACE requirement. The unit will be deployed to Sultan Babula Airport on Indonesia's Sanghi Island in response to a territorial dispute in the South China Sea. And during that time, I'll need to provide an on-the-ground brief to an air crew that is resupplying the island using the capstone common operating picture that I'm building and the objectives that were mentioned in the last slide. Doing that, I'm gonna closely mimic the methodologies that I use nowadays for intelligence analysis, but in order to sidestep, any leaking any secret or top secret data, I'm gonna synthesize fake data. And prior to executing this, I'll make a series of fake intelligence reports and news articles and textbook chapters and things containing information that'll need to be fused into some sort of an intelligence assessment. And using that synthesized data, I'm going to train the AI chatbot. Afterwards, I can begin querying the data for local airfield data, threats to our position, adversary locations, and threats to any of the mobility aircraft that'll be flying in the area. And then lastly, I will find a way to move that information from the AI to the dashboard. So just to go over the process of how AI can enable GeoInt analysis, chatbots are really powerful tools and they rely on information that has already been indexed from the internet. So for this project, I'm going to rely on that previously indexed information, things like geographic locations, adversary doctrine, historic data, but then I can train it on synthesized data such as like imaginary weapons parameters and adversary order of battle, indications and warnings and such. And then once the AI is trained and it's ingested all that information, I can begin the intelligence process, which is processing the information, exploiting it, analyzing it, and then ultimately disseminating it to my customer, who is going to be whatever decision maker. For this scenario, it's going to be a pilot on the ground. So tailoring that intelligence process to this scenario, especially with AI, how does it work? First, in terms of processing the information, that's training the AI. Training an AI chatbot means giving it data like written material along with information about the context of that material. The chatbot is going to use this data to learn patterns and structures and then generate a response to some sort of user input. So essentially it'll answer questions that I ask about it. So just a quick example for this project, I can give that chatbot a fake report that says something similar to, the F-1000 fighter jet carries 2 bombs and flies 1,000 nautical miles on a full tank of gas. That'll take me to my next step, exploiting the data. And the way I exploit data for the intelligence process using AI is done by querying the AI. I can now rely on the data that I have just trained it on and the index data like geographic locations in combination. And I can ask it something similar to, if this F-1000 fighter jet is in Sao Paulo, Brazil, can it strike a target in Rio? And it'll give me an answer. And it'll probably say yes, because Rio is less than 1,000 nautical miles away from Sao Paulo. And then analyzing that data is done by challenging the information that I have now received. I can challenge the AI's data by asking it more focused questions about a particular piece of information, but it could also be done by corroborating just the output on my own. So for this scenario, that F-1000 fighter jet can go 1,000 nautical miles, but the AI doesn't account for concepts like bingo fuel, where sure, it can go 1,000 miles, but if the plane needs to turn back to refuel or has the necessary support to go the distance to the target, is it going to fly 1,000 miles and just crash, or can it only go 500 before it needs to go back home? That makes a difference. I already have the basic tools on my computer and in my hip pocket too to create information about something like Sao Paulo on a map that would tell me if my location was actually in immediate danger. But I can also test it with different inputs or evaluated sources as well. And then as far as dissemination goes of the information, it's simply just the movement of that output data into the common operating picture dashboard. So at the end of this project, what will I hope to achieve? First, accurate AI generated data results. The upswing to training the AI is that I am able to monitor and maintain 100% of the knowledge that that's being used to feed it. I know what is true and what's not true in this scenario, and therefore I can accurately measure the responses of the AI against the information that it's been trained on. Using that information, I can measure the scenario with something like a confusion matrix, and I can compare those predicted outputs of the AI against those known training inputs. Next, the populated map of the operating space. This is the most important part of the capstone. Is the dashboard showing blue and red force locations. If I can't generate an accurate visualization of the threat space after all of this, then the whole thing will have been a total wash. And then lastly, an increased efficiency compared to the modern tools that I had talked about, those big, bulky, labor-intensive tools. If I can hyper-focus modern GeoInt processes into a less cumbersome and resource-intensive application, rather than have the tools that we regularly use today to conduct analysis in the degraded environment, this entire thing will have been a success. So in conclusion, our current geospace, our intelligence methods are not conducive to the new and emerging doctrines, which require increased responsiveness and adaptability. The lack of corresponding GeoInt doctrine and supporting tools, it places the air mobility intelligence community at a disadvantage right now. So the goal of this project is to create that dashboard, which will serve as an intelligence tool for military analysts that'll meet ACE needs while using minimal equipment and is supported by artificial intelligence. And pending any of your questions, that's all I've got.
All right, Jared, thanks a lot for your presentation. Looks like you have a couple of questions in the chat window.
Okay. The first question is, have I thought about the flexibility of new technology to train or seed the AI to the new threat possibility? And is this just an external resource, or will this ever get pushed out to boots on the ground? Because the Achilles heel is the number of analysts, correct? That is definitively the Achilles heel right now. Those are really good questions. Think the flexibility of new technology to train it to the new threat possibility. So that is more or less addressed by the fake inputs that I'll be giving it. Something like a chatbot can be moved to what we call the high side, which are like, our secret and top secret networks and everything. And we can then train it using the information that we hold on those networks. I think that answers that question. And then is this just an external resource, or will it ever get pushed out to boots on the ground? Ideally, this will be something that gets pushed out to boots on the ground. A lot of the military community right now is struck by I call it the good idea fairy, where they want to be faster, but they just keep buying more things, and nothing ever gets simpler. And what I'm trying to do here is leverage AI to not only speed up our intelligence analysis, but also to simplify the process and kind of narrow it down to just like, we need these one or two things to do it, rather than this myriad of tools. I hope that answers that question. The next question is, how will you go about training an AI to understand geographic locations and relationships? A major limitation in current chatbots for AI, as well as automated image generation methods, is that they don't seem to be trained on spatial organization or relationships. In essence, they seem to be totally fine with hallucinating a new synthetic geography versus sticking to real boundaries, locations, and their relationships. That is a really good question as well. You will never be able to fully remove the I call it the man in the arena. The intelligence analyst is, at the end of the day, it's only going to be as good. The intelligence is only going to be as good as your analyst. So something like an AI chatbot, it really has to be seen as a tool to aid you rather than something to, you know, just do it for you. So training it to understand things like geographic locations and relationships, you can, I talked earlier about how something like ChatGPT has indexed information in it, and you can ask it simple things, you know, how far is San Antonio, Texas from New York City, and it'll give you a rough estimation. But at the end of the day, that information, it does need to be corroborated with my own analysis as well. So it might speed it up, but at the end, it's something that I need to check on my own as well. So you can train it to understand geographic locations and relationships, but ultimately you should never just let it fly on its own. Like you said, it tends to hallucinate those things, and you don't want that to happen. So always check. Internal resource. Hybrid analyst, you see something like this helping my job, which, sorry. So Crystal, I actually don't know what a hybrid analyst is. And what sense can it could definitely help your job, I'm sure. I'm sure there's a way, but what does a hybrid analyst do?
It's essentially all like GWent. I
Okay.
don't know how to explain it on like
an all source analyst or
I
fusion?
do a little bit of everything. And
Okay.
then GWent, like a little bit of everything.
I will say 100% yes, this can always help your job. It's so the tool that I'm talking about, the common operating picture, is more so for literally like a guy in a jungle who has to rely on, you know, his phone to all of a sudden, you know, tell someone where a threat is, or how do you even go about acquiring the information as to where a threat is. I think as a hybrid analyst, it can definitely help you as well. Something like this is, like I said, it's simple, and at the end of in today's military, especially, nothing's really simple anymore. And we've kind of lost our way with technology and trying to, we're overburdening ourselves with all these programs. And something like this is we call it a pointy talkie, where you can have a picture and you can point to a spot on the picture and say, hey, this is, you know, this is a dangerous area, or this is where a bad guy is, or to the best of my knowledge, or to the best of my confidence, you know, this is an adversary location and we want to avoid it.
Yeah, I use so many tools. So
Right. So do I. And that's what's driving a lot of this. It's like, I can't bring all of this with me downrange.
okay.
I have a kind of a follow-up question here. So in a time frame thinking, is how long would it go from taking scratch intelligence to produce the map showing where the threats are?
In the best case scenario,
best case scenario, yeah.
In the best case scenario, something like this, depending on how experienced your analyst is with not only just GeoInt, but also with using an AI tool, I would say a matter of hours. So for the scenario that I built, where we're on this contested location in the South China Sea, there's a lot of rapid movement that happens in that area. And so if my way of going about it was, if I knew that there was a mission incoming and I need to turn this individual around and send them back into the sky, I need to know ahead of time what they're going to be facing down if anything's changed compared to when they left their original location. So knowing that, that usually affords me a couple of hours to go in and start querying the chatbot saying, hey, has there been any news articles or any Twitter feeds, or has there been any indication that anything has changed in the battle space in the past 24 hours? And then relying on indexed information. So say information that was already available on a network, relying on that indexed information to calculate what amount of risk this pilot is taking.
All right, thanks. You have another question, but I kind of want to ask you another question too. Is something important about you mentioned is the idea of certainty in your analysis. Do you have any metrics that come along with the AI or in terms of certainty of what the AI is proposing?
I think that there is a level of reliability in AI, but when it comes to conducting intelligence analysis, I do not think that, at least at this point in time, handing something like analytic tradecraft, so your certainty and your confidence levels, over to an AI, I don't think that's a wise decision. So as far as this tool goes, I would leave it out of the equation, and I would rely on my analyst to say, okay, now that AI is part of this analysis and everything, I mean, it'll certainly increase your confidence, but it doesn't necessarily, I wouldn't rely on it to drive that certainty at all, or to calculate that certainty.
All right. You have another question in the chat window?
Help you working with thousands of hours of sensor data. Oh yeah. To detect changes in visuals, things to alert analysts and changes in other duties like that in the beginning rollout. What do I think? I think that is 100% helpful. The biggest problem that I face down being an intelligence analyst is, I mean, on a daily basis, almost like terabytes of data that I have to sift through to find what I'm looking for. I had said earlier that this is, my understanding of AI is pretty fundamental and just elementary at this point. So that's why I'm using something simple like a chatbot. I know that there are other civilian partnerships and industries out there that are capitalizing on things like AI for doing that exact thing, where they're doing change detection and they're using like full motion video and stuff to alert analysts. But the problem is you have to be plugged into that specific individual, which is great, but that also comes with things with other uncertainties in terms of classification, and it incurs a lot of expense as well, because those are government contractors. And at the end of the day, this tool is to it's designed to be just good enough. This whole rapid mobility and agile combat employment, it's gonna be way more risky than what we're doing now. And this tool has to be good enough to present something, your best guess, because we won't have that luxury of being able to rely on this entire network of people to watch out for you when you're downrange. Have you looked at the different COP tools that are in use and how this bot would interface with those tools as an analyst, putting the info into the COP while checking the validity of the data the bot's produced? So checking the validity of the data is part of that exploitation part, where you're challenging the data that's been given to you, and that'll rely on a good analyst rather than a good bot. You have to kind of know off the top of your head, or you have to have the information in front of you to be able to challenge that information. As far as the different COP tools that are in use now, yeah, I've looked at a lot of those. In fact, I use quite a few of them. And I think in a scenario such as agile combat employment, where you are force feeding personnel and equipment very far away from you, this bot, I would, in an ideal situation, it would interface with those tools via a data link in a in the best case scenario, I would have it be a one-way direction where you have this backdrop of intelligence network feeding the AI itself, and really the person in the theater cannot access that information, if that makes any sense. They're only able to query the analysis that's being given to them. They are not able to give back that analysis, because their sole job downrange is disseminating that information to the next person, rather than sending something back to the intelligence network or the intelligence community. But I do think interfacing with those tools, it would be very useful. One of the tools I interface with on an unclassified level is Flight Radar 24, where you're able to monitor civilian and military air pictures in different areas. And I think that would be a good example of how pulling a layer to that tool could be useful.
All right, Jared, thanks a lot for answering all those questions. Very interesting presentation.
Thank you.
And next up, we have Madeline.
Everyone.
So if you want to start sharing your screen, that'd be great.
Yeah.
Thanks, Jared, for sharing your contact. All right, we see your presentation. So whenever you're ready, you can start.
Okay, great. Hi, everyone. Thank you for joining me tonight. My name is Madeline Stevens, and I'm going to be looking at property values along the Colorado Front Range in conjunction with protected land. Up front, I'd like to say thank you to Professors Floor and Kessler. I've had a lot of help along the way. So basically, for people who aren't familiar with Colorado, the Front Range is called the Front Range because it is the gateway to the Rockies. And if you've ever flown into Denver Airport, that's what you're seeing. So here's a little overview of what I'm going to go over today. And if you're worried that it's going to be over too soon, you can see that there's a little bar along the bottom here so you can track our progress. So I work for a land trust in Utah, and we work with quite a few different types of landowners. We work with developers, we work with conservationists, we work with local and federal government. If anybody's seen Yellowstone, that's kind of exactly what a land trust does. Jokes aside, we do work to preserve land, and most landowners really have an interest in preserving the land, but almost every single one of them takes the tax break. And if your local government, you're not responsible to pay taxes, but you still want to be a good steward of taxpayer money. So it's kind of important, the financial aspects of these land transactions. So it's kind of given me a gut feel over the years that there has to be some kind of financial incentive for landowners. And I also have a gut feeling that the land next to open, conserved wild space is more valuable than land next to, say, a shopping mall. So that's what I wanted to look at in my study. So to be more precise, I'm looking at the visible patterns between protected lands and property values within the Colorado Front Range. There are lots of different ways to protect land. Most people are familiar with national parks, but conservation easements are a great tool for that as well. What we're protecting are things pretty basic like air, soil, and water. You are also protecting scenic view sheds, outdoor recreation opportunities. So we're looking at the spatial distribution of land values to determine whether those values are influenced by proximity and adjacency to protected land, and also whether different types of land have different levels of influence. Out west and in the Rocky Mountains in particular, we've seen incredible amounts of growth and development. The Denver region within the Colorado Front was touted as one of the US's fastest growing metropolitan areas decades ago, and that has not slowed down. This is driven primarily by job opportunities, but also by access to outdoor recreation and quality of life. The irony here is that the more people are attracted to these types of areas, the less attractive they become. So Colorado landscapes are pretty iconic for all sorts of recreation, whether it's trout fishing or, of course, skiing. Some people move to places like this just looking for a little more solitude or less government regulation. Colorado itself has amazing amounts of open space. About half of the state is actually The western half in particular is primarily national forest land. There's lots of parks, grasslands, and even a lot of local municipalities maintain open space in the form of parks and even wild space. This makes for a really nice place to live, and the real estate prices are reflected in that. The pandemic only strengthened the trend. Americans are moving from urban centers like New York and San Francisco to non-metropolitan areas in rates not seen since the mid-2010s. And of course, that includes areas along the Colorado Front Range. This isn't limited to the US, we see this trend globally. Bath, UK is a great example. People have been going there for health and wellness for probably centuries. We know that people support the purchase of open space. We see this through the passage of open space bonds at a county and even a city level. We also see people donating conservation easements valued in the millions. I mean, I see it monthly. So I think that this is proof that not just individuals, but also communities value this type of land. It's definitely a finite resource, and it's ever more finite after development and also after conservation easements are in place and other types of land protection. But it's also really hard to value. The best method that people have come up with is to value the foregone development rights. You kind of do a before and after appraisal, best use being development generally, or sometimes farming. And then after that case, it's the loss of those rights. It's really hard to do some kind of comparable on that though, because I guess I'll take the example of a 10,000 acre ranch with a blue ribbon trout stream and calving grounds for Rocky Mountain elk. I mean, the odds of something like that selling in the same county, even in the same year, are pretty rare. So it's pretty hard to find a comparable. It's not like, you know, a house in a development. So that being said, people have tried to value open space and wild lands. Many authors have found strong connections between open space protection and proximal home price increases and even tax revenue increases. Some authors, Reeves et al., have gone so far as to state that in some cases, conservation easements held by public entities can actually increase the tax base. So much so that they can actually fund the purchase of more land. So conserved land doesn't just protect quality of life, it also protects crucial resources like those mentioned before. It also appears to be a better return on investment than developed land. The basic concept is that cows don't require schools or the police. So moving on to the goals and objectives of this study, I'm interested in how conservation easements impact property value in various scenarios. There are a lot of different types of open space. You know, you can have an easement on a working farm, you can have a park with a baseball diamond, or you can just have wild space. But many authors have found that all of these different types of open space, and those authors include Reeves, Middle, and Votstis, that they have actually increased nearby housing prices, both in the US and abroad. But there's more work that needs to be done specifically in relation to conservation easements and land valuation and in comparing urban and rural settings. So that's what I've done. I've used ArcGIS Pro 3.1.0 and publicly available spatial data. The Colorado State University has a really great data set looking at, it's called COMAP, the Colorado Ownership Management and Protection Service for protected lands. And I've also looked at land cover provided by the Southwest Regional Gap Analysis Project. So I've looked at various types of open space, and those are all the ones that are contained in that COMAP data set. So, you know, US Fish and Wildlife Service, US Forest Service, Tribal Lands, Park Service, NGO and Land Trust lands, federal, state, private conservation, Bureau of Land Management, local and private. And that's because not all open space is the same, nor are all the landowners. The BLM, for example, might dramatically change the land use, leasing out mineral rights. That's very different than a national wilderness. So even with these 11 categories, there are quite a few different land uses within those categories themselves. So for example, the local category covers everything from parks to cemeteries. And I think it's pretty obvious that there might be a difference in land value for someone living next to a cemetery as opposed to a park. So I don't want to dwell on it too long, but I did want to go into a little bit the different types of lands that are covered by each of these categories, because this is a central part of my study. So Fish and Wildlife Service includes mostly wildlife refuges, but it also includes fish hatcheries. Forest Service is, of course, national forests, but it's also grasslands, monuments, recreation areas, experimental forests, wild and scenic rivers, archaeological, geological, and mineral reserve areas. The National Park Service is national parks, but also national historic sites, monuments, preserves, and recreation areas. BLM also includes wilderness areas, areas of critical environmental concern, conservation areas, national monuments. The tribal lands in Colorado belong to the Southern Ute and the Ute Mountain Ute. NGO and land trusts, that's pretty self-explanatory, but it does include lands that these entities hold the conservation easements for, but also ones that they own outright in fee title. Federal lands exclude the above mentioned categories and include things like the Federal Aviation Administration, the Bureau of Prisons, Army Corps of Engineers, Reclamation, Agriculture, Commerce, Defense, and Energy. Most of this acreage in this category is actually not protected land. So state lands include the Colorado State Land Board, Colorado Parks and Wildlife. So this spans from universities to parks to fish hatcheries. Private conservation are privately owned or managed lands that include greenbelt, and those can be either deed restricted or natural areas or parks. Can even be trails or trail accesses, golf courses, cemeteries, state habitat areas. About half of these are permanently protected via conservation easements. Some of them are just deed restrictions, which are not considered perpetual, but still limit development. And then finally, we have local lands. These are owned by city and county municipalities or joint. These could include dog parks, fairgrounds, golf courses, again, greenbelt, museums, natural areas, and even swimming pools. So these are a much smaller category of these are protected. About 500 out of 8,000 of these entities are actually permanently protected. And then finally, there's this private land category, and that's kind of just included to show the completeness of the data set. That's just privately owned land that is not protected whatsoever. But it was important to look at because it showed that the entire state was in fact covered by this data set. So moving on to something a little more interesting. Here are the land cover maps for 3 representative counties. I selected just 3 in the Colorado front, largely because there were data limitations to the parcel data. Not every county, in fact, only half of them in Colorado actually included property value in their parcel data. Some included nothing whatsoever. So I selected these 3 counties because there was data, but also based on census and environmental justice data, and just because they represented dramatically different land use in the land cover. As you can see here with Adams County, it's primarily agriculture there in the red with a small amount of development as you get close to Denver. Denver is almost entirely developed, whether it's serious development or low-grade development. And then Jefferson County is kind of a mix. Up in the corner, you have some development, and then you get more into the ski areas and the national forest, the west. And in terms of pollution, Adams, as you could guess, in the agricultural areas is much better off than as you approach Denver. Denver is in the 80 to 90 percentile of pollution for Colorado, and Jefferson is about half and half. It's much less polluted than Denver. And Colorado as a whole is about 50% in the 50th percentile for the nation. So here is kind of a histogram of the property values. You can see they're all very clumped. The median value is actually between $1.9 to $2.6 million an acre, which may not be surprising to anyone who's looked at property in Colorado, particularly in the Front Range. You have a lot of small parcels, as you can see with that land cover map. And I think that this is why the values are so high per acre, is that it's just a highly developed area the closer you get to Denver. I'm guessing that there are probably quite a lot of condominiums, and that probably skews the parcel data. And this is a good time to mention that I've excluded any parcel data that has a 0 value, and that will include a lot of the government entities. So like half of the state of Colorado. And as we'll see, there's quite a lot of that land in these 3 counties. And it's also worth mentioning that in Colorado, for tax purposes, agricultural land is only valued at 29% of the full fair market value. So that is also reflected in Adams County having a lower median value. And then conservation easements themselves also influence property values for the parcels that they are in place, because you're losing your development rights. All right, so did a lot of data cleaning. Parcel data is particularly messy. ArcGIS Pro apparently allows for incomplete polygons. I found a lot of self-intersections and duplications. I used several tools. I used the Euclidean distance, zonal statistics, feature to point, and kernel density. And then I overlaid the COMAP, those land category data layers, on the kernel density layer to look at property values in relation to protected land. I created probably close to 60 bivariate maps where I was looking at the distance from the protected land and the property value, and identifying where there was an adjacency increase in property value. And so that was a lot of visual inspection. And then I also did some bar charts to really display the value per acre to capture the nearby property values as opposed to adjacent. So I looked at median distances for less than or equal to 1/8 of a mile. And then I compared that to the same property value in relation to the distance of 5 miles from my protected land to see if it increased or decreased with distance. And so I think this tells the story pretty well. You can see that there's a significant difference between the less than or equal to 1/8 of a mile as opposed to 5 miles. So this is for all 3 counties, and it's only the local land category because that was the only one that basically showed a difference in both adjacent and nearby properties for all 3 counties. And it's a pretty strong difference. I think it's a pretty strong correlation. So not all the counties had all of the property types, and none of them actually had tribal or Park Service lands, so I wasn't really able to assess the impact of those categories. And then there was I couldn't find a trend for all 3 counties where the same protected land category did not influence anything whatsoever. So I basically broke it down into no influence, weak influence, and potentially significant influence in terms of positive property value. And again, I excluded 0 property values. Okay, so I'll dive down a little bit deeper into the bivariate maps just so you can see what they look like. So the bright magenta adjacent to the bright orange is showing where you have local protected lands and then a definite increase in property value nearby. So you can see this, it's a little cut off for Jefferson, but in all 3 counties, I definitely saw this throughout. And when I was able to pan and zoom a little bit better, I could see that it was a pretty strong trend. So for Adams County, you can see here to the left, we're getting closer to Denver. So you have those denser parcels and increased property values. It's hard to tell at this scale, but when I was able to zoom in doing my analysis, some of the trends were pretty clear. So you can see which lands are represented. And the fact that the far western side is significantly more developed and generally has higher property values. So in this one, there was, of course, as in all 3, a strong correlation between the local protected land category, and there was a weak NGO and land trust correlation to potential increases in nearby lands. The bivariate mapping for adjacent NGO and land trust land showed no increase. And the rest were weak correlations. So here's that same kind of chart analysis for Denver County. So you can see there's a lot more variation. Again, local is very strong correlation with a very significant drop in value as you move away from the protected land. Like I showed you with the land cover map, it's a very heavily developed county with a lot of small parcels and very high property values. sorry, I skipped ahead. And so yes, the strong correlations for this county were, happily for me, since I work for a land trust, the NGO and land trust category and local. There was a very strong correlation with state and federal for adjacent. When I looked at the bivariate mapping, which I'm not showing here, there was kind of a weak relationship. And then here's just kind of showing that there's a little more of an even distribution in the high property values. The darker color here is the higher value per acre, so it's not as clustered as in Adams County. And then again, here's our bar chart showing that strong correlation between the NGO land trust and local land categories for Denver County. Then we move on to Jefferson. And just as in the land cover map where you had kind of the development clustered to the northeast, similar with the property values, they're also clustered similarly. This county is a little different than Denver in that it's divided into a very natural kind of on the western side and then more developed on the east. And then here are our charts showing quite a few solid influences. It's not just one or two land categories. We've got, you know, adjacency is a very solid correlation for state and private conservation lands in addition to those local lands. There's kind of a weak, when I looked at the bivariate mapping, there was a weak correlation for the U.S. Fish and Wildlife Service, but otherwise it was all quite a few potential strong impacts. So moving on to the discussion section of this presentation, though I didn't find that strong correlation, I was hoping that every parcel next to a land trust protected land would increase in value. The influence of local lands is still a pretty exciting result. There have been some previous studies using the same data set by Kling et al., and they looked at just Larimer County in northern Colorado, and they found that only proximity to national and state parklands had a significant positive impact on property values. So I kind of found a different trend in my county. I also didn't find a consistent connection between quantity of protected land. For example, the highest percentage category of protected land in Adams County was state, and Jefferson was U.S. Forest Service, but both of those exerted a weak potential influence on increased property values. For Denver County, though, I did find a connection. The largest category of land in terms of percentage of, in acreage was local and NGO and land trust lands. And those also showed a potentially strong influence on increases in both adjacent and nearby property values. And then I would also say, importantly, a trend I noticed is that developed land cover areas in all three counties correlated with higher property values in relation to protected lands, as well as just in general. So this to me seems like a preliminary potential confirmation that protected lands have a larger impact on increased property values in urban settings as opposed to the more rural settings in the eastern portion of Adams County. Apologies. So the overall study impact, I think, is that there's basically a positive impact on various types of open space and protected land on housing prices, just like other scholars have found, including Reeves, Mitchell, and Bustis. And then I also think that there are some public and private policy implications. When public entities hold land adjacent to open space, that land likely increases in value, meaning they can increase their tax revenue and they could potentially even fund land conservation. The fact that protected lands potentially increase adjacent or nearby property values is probably of interest to private investors as well. And then I also think that there's a nexus between the rural and urban context that can inform your conservation approach. For example, in Adams County, which is relative to the rest of Colorado, has a high ranking of social vulnerability, according to the CDC's Social Vulnerability Index. To me, that suggests that more practical agricultural easements will likely have more impact than luxury mountain amenities. Low-income farmers are less likely to benefit from a charitable donation, but more likely to be incentivized to protect their land if they can get paid for it, and also continue their living on the land and working those agricultural farms. And also, I think given that many rural areas are not currently zoned for small lot development, the foregone development rights are just not worth as much. So purchasing them to protect them, or purchasing even just the easement as opposed to the fee title, is a good way to reach a segment of the population that probably has vital environmental, resources in their lands but can't afford the charitable donations. And then on the opposite side of the spectrum, we saw that Jefferson County has a low ranking of social vulnerability in comparison to the rest of the state, but also many, many categories, local, state, federal, NGO, land trust, and private conservation lands that has significant impact on property values. So I think, the study results show that not all protected lands and conservation easements are the same, whether the land or the land or the incentives infrastructure, but optimizing land conservation in a specific context will benefit the most people and the land. So in terms of future research, I think it'd be interesting to expand the study area to look at all of Colorado and to look further into these co-map subcategories so that we could look at more tailored conservation approaches. I also think Utah would be an interesting future study area, partially because I live and work here, but also because we also have large tracts of existing protected land, conservation easement purchase funds from states and counties and municipalities. We have a pretty healthy open space bond program. I also think it'd be interesting to compare the property value influence of conservation easement protected lands to other protected land categories. And then I also think looking at the proposed proportionate acreage and number of acres impacted would be interesting, because it would kind of level those variations between the counties and protected land categories. And I think it would give a more accurate accounting of the significance of the impact. I mentioned a few challenges and limitations earlier. Colorado is an open data state, but that data wasn't always available. Like I said, parcel data was only available for 32 of the 64 counties, and there were wide disparities in the detail provided within those data sets. I also think edge effects influence my data. Whether a state or a county boundary is utilized, there are always nearby easements or protected open space outside of those lines. One great example, if you've never been there, I suggest it, is Dinosaur National Monument. It spans the Utah-Colorado border. And then I think this is pretty much the biggest point. More research should be performed to rule out coincidence. Just because protected lands are adjacent and nearby to relatively high property values does not confirm independently that the proximity to protected lands is what is causing the high property values. Moving along to the conclusion, land protection via conservation easements and other development restrictions are a means to combat climate change, biodiversity loss, shrinking open space and agricultural lands, increasingly overburdened public lands, especially as we've all seen during the pandemic, and decreasing quality of life for present and future generations. I think that my research demonstrates that land values can increase with proximity to protected land, mostly in urban areas, and at least within these 3 counties along the Colorado Front Range. Clearly, local protected land had the most consistent impact on increased property values, and knowing this allows us to optimize conservation approaches and financial incentives, resulting in the protection of vital resources. So I guess just to throw it out there, this slide may not prove my point, but what sounds in your backyard do you think will increase your property value? Cars honking or the majestic oak? I hope you guys can hear that. The volume.
Yeah, no elk, sorry.
So for any of you who have not gotten to hear that in the wild, kind of an alien sound. So that brings me to my references and any questions if you have them. I see quite a lot going on in the chat, but no questions. So yeah, feel free to hit me.
Yeah, great presentation. Looks like you have a question right now.
Okay. what are one or two things that surprised me about my project process that you wish you knew at your proposal stage? I definitely underestimated the amount of time data cleaning would take. And I think another key lesson was that just because you do some kind of spatial statistics or analysis and it spits out results does not mean that it was successful. I think, you know, sometimes it can take so long to get to that stage where you see, where you get, or at least for me, to even get the tool to work. I was just happy that it worked. And then, you know, finally getting into the diagnostics and seeing like, oh, actually it didn't really. But yes, data cleaning took quite a lot of time.
Yeah, those are great pieces of advice. So thanks for asking that question, Travis. That was great. I had a question looking through your bar charts with regards to different kinds of properties and then the property value. I noticed that I think it was it might have been Jefferson County. There was a huge disparity between, Jefferson County, huge disparity between the BLM lands. And you made mention about Utah. Of course, BLM owns a ton of property in Utah. So can you speculate a little bit, you know, why is there so much change between BLM compared to like Fish and Wildlife, where the difference isn't that dramatic?
Sure, I'll throw Utah state lands under the bus a little bit too. When I talk to landowners, they often don't view BLM as protected land. And the comment about the state lands is that if you're next to those lands, you're either going to have a casino or an oil derrick on your next to your property. And I think BLM has a very similar perception, at least in Utah, because there are so many mineral extraction leases. So people really just don't even view it as protected land. Sorry if there's any BLM in the audience, but
no, that's very interesting. So is there also a perception that living next to BLM land isn't really worth it?
Yes, yeah, that's definitely the feedback that I've gotten. Often, so we have kind of a landowner worksheet that they provide when they're kind of pitching their project to us. And often people won't even include adjacency to BLM as, you know, as being a positive attribute. You know, they definitely want to talk about national forest lands, and state parks have a little bit of a bad reputation as well, though I'm not quite as sure why that is. Maybe because it's not viewed as permanent protection. I've definitely seen local city parks that are beautiful, just like right in a valley or a canyon, turn around and get developed. So I think people are aware of that.
Yeah. All right. Well, thanks for that perspective.
Sure. Thank you all for listening.
I have another question for you, actually, in the chat.
Do I think climate change will impact this relationship? Like thinking of wildfires near Boulder and the dangers at times of living near open space. So I know that we as a land trust put a lot of effort into looking at climate change. And in fact, we're conserving a ski resort on the premise that eventually it's going to be a hiking mountain. So yes, I do think we do get a lot of concern. I worked on a trail crew for a while for a city nearby, and residents were constantly calling to have us cut down vegetation on our city land that was adjacent to their houses because they were concerned about wildfire risk. So yes, I do think that that is a concern that people have, that just my little pitch for land trust, you know, we're supposed to be managing that land, and that's part of that management strategy. I think our lands are in pretty good shape, but that's probably not universal.
All right, Madeline, if you could put your contact info in the chat, that would be helpful if anyone wants to contact you later.
All right. I guess I'll put my real one in there since I'm hopefully graduating.
And then I want to take a moment to thank all the presenters for a great job on tonight. Tomorrow at 11 a.m. Eastern is the second round of 596A presentation. So mark that on your calendar. We'll look forward to seeing you then. And have a good evening. We'll see you later.